Um, okay, thank you so much. And welcome to my presentation. So the title of my talk is Formalizing Concepts in the British Colonial India Corpus, Fixing Computational. Um, so using a computational modeling approach. So I'll give you a brief context about this project. It was started as part of ADHO sponsored project titled as Digital Innovation in Water Scarcity in Coimbatore, India. So in which I worked as a postdoctoral research associate at the University, UK. So part of the main aim of this project is, I think it's blocked out because I don't know. Okay. Still, okay. So the aim of the project is to extract water-related features in the British India colonial corpus and maps, particularly for the region called Coimbatore, which is in the southern region, which was also part of the Madras presidency during the British colonial time. So I used various like digital humanity methods, digital literature methods to study these water bodies issues and other environmental features for this region called Coimbatore. So part of this project is still, although it is completed already, the fund got over, but I'm still working on it, like because it's my second kind of after doctoral research. This is my second baby, so I'm still working on it. So part of this project, I collected 32 texts that specifically focused on this region. So these are the texts collected from different online websites like Internet Archive, Google Books, and some libraries from India as well. So then, like before delving into my the main theme, so I would like to briefly give you some context about the British colonial India. So during the British colonial time in India, the officers were very much focused on surveying and mapping Indian India, like the colonial subjects, starting from culture, geography, everything, like everything is data to them during the time, so they collected as much as information they survived. So basically to control the land and people to establish their government. So there have been many studies conducted on this basis. So during the survey and document process, as I mentioned, they started looking at even the granular details of natural history, political economy, and every conceivable species of inquiry into native society as Evelyn, I'm sorry if I pronounced that name wrongly, pointed out in his dissertation. So also the other reason, not only just to control the land, but also for the revenue purpose as well. So how to monitor the revenue, collection from the colonized subjects. So in this case, how are the documents, how are the surveys, how they look like? Because as we started with, they collected like very granular details. So which means the surveys and documents have kind of intricate, like the format is quite non-standard because it's kind of even chaotic kind of because they put just so much information in just one document. I will give you a brief look at like for this Madras district manual for this place Coimbatore. You could see like numerous topics have been covered. Of course, it's a manual. I understand, but how do we use it for like today's purpose of like extracting information by using computational approaches? So this document has water related information at the same time, culture and then like irrigation, forest, you can like find any, just so many topics. Communication, education, public health. So then I collected various surveys and documents related to Coimbatore. So they come in different formats as well. Like some are just quite descriptive, some are analytical, some are like data. So I used basically just a keyword search to extract the information. Um, so I tried first in the beginning, like what kind of computational modeling would be really helpful. And then like semantic types such as topic modeling, like land, water, administration, they can provide this kind of information. But what about a specific questions like water, just only water or population or cost, something. So then how can we build and study colonial India corpus for topic specific research questions through computational method and tools? In general, in humanities, like how we usually study document by using close reading, right? Like because the concepts are very much plural and complex, so it can be also multiplied based on the information that we can cover by using additional resources. But on the other hand, in digital humanities, it's more about like formalized concepts and models. So these formalizations are, these concepts are mostly unstructured, but digital humanities cannot study unstructured data. It needs to be formalized so that we can use some, algorithms or codings to extract information. Um, DH, usually when we curate the corpus, we use various, features to curate the corpus. For example, use concepts or topics or index or any kind of representative. But little research or some has been done to curate non-standard corpus like this one. And when it comes to studying British India colonial corpus, there was no study previously to look at these kind of complex issues. So then I propose this concept-based model to extract various related information in the. It's kind of experiment. I don't propose any solution here. It's kind of a problem identifying by using experimental method. So what I mean concept-based method model, we could see that um, so I divide this model into three categories. First, as a primary model, that is something like reflect the main concept of the entire text. So when we say then sub model of that within that text, which means like there must be, even though it's a primary concept, there must be other like sub information can be also written inside the document. So that I call them as sub-model. I will quickly provide example of this as well. So then the collection of, so we can categorize a primary model, sub-model, and then the main theme of the entire text can be just a primary model. And then each units or sections, whatever chapters can be sub-model. So all these together can form a larger model. So I can provide an example of this based on my understanding of the corpus I collected. For example, so the primary model, that the text is about water bodies and canal company. Canal company is something like during British period, they started a department of canal company because they want to control land and revenue. So they want to also then look at the river water bodies. So they started, and there is a particular document that focus on water bodies and canal company. But if you go and read, there are much more information. Water infrastructure, land, dam construction. So that I call them as sub-model. And then primary model, there are different categories of documents, as I mentioned in the beginning, but you could easily connect them. For example, in the last one, there is about a river and channel. This is particularly, this document talks about public and investment, but within that category, so there are investments about dam and like investment about river and building channels as well. So this particular model can be connected to the first one as well. So where like dam construction. So you could easily connect within the sections or units of the sub models based on similarity. So I theoretically understood and the complexity inside the document, and then I tried some experiment by using affinity propagation algorithm. The reason why this algorithm was introduced by Brandon J. Frey and the Duke at University of Toronto in 2007. The primary advantages of this algorithm, it can be applied to small data set like mine, and then it also decides the number of clusters on its own. And there is one more additional advantage of this algorithm is that it just it tries to provide some representative for each cluster. When I provide more examples, I think it will be easy to understand. So the how I started my experiment. I started first identifying the sub and primary models. For example, I simply divide the entire body of the text into a few categories. For example, just using simple HTML tags, for example, table of contents and table of body, and the close section of the body at the end of the document. And also if there are chapter divisions and then chapter divisions also I tagged by using simple HTML tags. I didn't know much about the TEI, now I'm thinking going back to the TEI as well. This was done during the COVID-19, so that time it's kind of you're working on my own. So what are the challenges when I, in curating by using HTML tags? So as we, like the reason why I said non-standard, because all the text did not have even proper table of contents. Some of the text just the description, and some of them like a table of contents, and some of them did not have any divisions or sections if the text runs throughout the document. So that was one of the challenges I encountered. And then I extracted top 15 words in each cluster after certain trials. So this affinity propagation is also kind of a k-means algorithm, or you can say topic modeling. So it provides chunks of words together based on the similarity. So then I want to look at the words, how they appear, like whether they're similar, if there any problem. So how can I move forward? So I extracted top 15 words in each cluster after certain trials. So I named them the sections as heading cluster, that is of models, and then the entire primary model as text cluster. So then I exported into CSV file. So the first visualization, it might look complex, but yeah, I'll explain that. So this, blue represents the primary model, that entire text clusters, number of clusters, and then red represents the sub model. So you could see that I think I said opposite. So the blue represents the submodel, red represents entire primary model, because you could see that they are more in number. That obviously because when you apply any algorithm, k-means or affinity, whatever, to units inside the text, of course they bring up more clusters. It's a well-known one. There is no surprise. But I looked into the details of some of the text to understand, what exactly happened. So this text, a journey from Madras through the countries of Mysore, Canara, and Malabar. So you could see that the clusters appeared more, but the red clusters here, the submodel, text clusters appeared very less. So let's look into what the text says exactly. So this is a Scottish physician who surveyed some of the regions in South India. So he surveyed the culture, the natural resources, geographical locations, weather, climate, but it's kind of his personal understanding. So the entire format of this particular text is description, and divided into long chapters, like without any specific, headings or numerous headings, divided into 4 long chapters. And the text is very consistent and homogeneous. So that's why APA, this algorithm, did not pick up more clusters for the subheadings inside. So let's look at the other one. This one is report on the administration of the Madras Presidency. Obviously, this also has a lot of information about water bodies, which is why I included. But the format of this text is so different. So if you look at here the submodels are very less, and the primary models are so much. The reason because it is kind of a facts, just information, like, to the pinpoint, like there are numerous headings inside. But still didn't pick up for the submodel. The reason because it's all facts, like, tiny paragraphs. Even just couple of paragraphs can be converted into units. So that's the reason. So these kind of complexities in the format of the text. Yeah, that's why I think I just explained this thing by looking at the chart. Okay, so let's look at the exact words that appeared for this cluster. So this is the model of the first text. So you could see I just highlighted some of the important information that it extracted. For example, oil, farmers and weavers, zamindars, turbines, irrigation. So I didn't clean the text by using lemma or stem. So that's why some of the farmer and farmers also appear together. Um, but these are the important nuanced information because oil and drugs also somewhere should be here. The drugs over there. It didn't have big bubble. That's because it appeared in only tiny paragraphs like here and there, but throughout the text. But couple of sentences because this Scottish physician he surveyed also tribal medicines, like how tribal people collect medicines, what are the drugs, what is the purpose, who used. So he collected those informations, but that did not travel throughout the text, that information. So that's why it doesn't have any big bubble. But by using this, sub model, I could easily identify this important information. But that got missed out in the big model. So this is the primary model. The entire text cluster into only 4 units, sorry, 4 clusters. It's randomly picked some representatives that phase doesn't make much sense. So when I looked at the keywords of these clusters, and it also does not make much sense because of course it just grouped similar words together. But still, like, those drugs, oil, iron, these are not much, traveled throughout the text, got missed out in the primary model. So this was the issue identified. These are some of the terms appeared inside in the big model, but obviously they are also equally important, but there are much chances to miss out some of the nuanced information. So my takeaways from this experiment is something like big data model always focus on the trend patterns, but I tried to provide both trend and non-patterns model. So how we can use for this kind of non-standard corpus. The second, like there are a lot of takeaways for me based on the trial and errors and experiments. I tried to provide only a few here. There are many challenges as well because not all the texts are equally formatted. So that is also one of the challenges. This model also allowed me to understand how colonial knowledge curated. So that is also one of the takeaways. I found it very interesting. This model, I won't say this is very successful, like something like unique or something. The reason because it's also based complex. It works based on how the format of your text in the corpus. I think that's it from me. Thank you so much. I look forward to your questions and then